Okay, we're going to look at something called integration by parts today. If you recall from earlier in the year when we looked at derivatives, we had the product rule. And the product rule said if you had two functions, in this case f and g, being multiplied to each other and we want to take the derivative of it, it would equal the first function times derivative of the second plus the second function times derivative of the first. And we went through on how to do that. Well, what we're going to look at today is, well, what if we were to integrate both sides? Well, from what we've talked about, we know integration and derivative are kind of opposites. So on this side, we'd be left with basically f of x times g of x. On the other side, we would have this integral over here. Well, like we said, we'd be left with f times g, those two functions being multiplied together over here. On the other side, again, we have this big integral with respect to x. Well, if you have two different things being added within an integral, we know we can split those up into two separate integrals, where each integral would still be integrated with respect to x. Then what we're going to do here is let's subtract one of these integrals over. So we're going to subtract this one to the other side. And if we do that, what we end up with is this. That says f of x minus the integral f prime g of x d of x equals this. If we just flip these two things around, this is known as integration by parts. And what it says is if we have an integral where there is a function times the derivative of some other function, this stuff on the right-hand side of the equation is what the integral is equal to. And that same thing is known as integration by parts and is often used with this formula as seen here, where any f of x becomes u. Any g of x we call v. Any derivative of those two functions then we would call, if it's a derivative of f, we're going to call it du. And if it's a derivative of g, we're going to call it dv. And so you end up with this integration by parts formula shown here. And that's what we're going to be using to help us integrate any functions where you have a function times the derivative of some other function. Now, when we're doing this, we need something to help us figure out what are we going to select as this function. Because if we can pick that right, then it should help us figure out the rest of the problem. So we have kind of an order that we're going to use to help us select what the function u is going to be. So you want to start at the top of this list and kind of work your way down. And whichever one you hit first, that's the one you're going to select for u. So if there is a logarithm involved in the problem, that is the number one choice. You are going to put u equal to whatever the logarithm is. If there's not a logarithm, then you're going to check to see if there's any inverse trig functions. If there is, that's the next choice for you. If you don't have either of the first two, then you would be equal to any polynomial. Remember, polynomials are just anything where you got like x squared, something like this would be a polynomial. If you have neither of the first three, then the next one is exponentials. Exponentials would be anything where the variable's in the exponent, such as these two. Okay. If none of those are there, then your last choice for you would be any trig function, sine, cosine, tangent, etc. Okay, so let's look at one of these problems. What if we want to integrate x sine x dx? Well, first off, we notice we can't just do a simple antiderivative here because you do have two functions multiplied to each other. Also, it's not going to work here to try substitution. We know substitution that we've done in the past where you say, okay, maybe we can let u equal sine x. Problem is, derivative here would be cosine x, and there's not a cosine x that we're going to be able to get rid of. So we would just be kind of spinning wheels, not going anywhere. This is a problem that we can use integration by parts to do though. So first we want to see what two types of functions do we have. This function is a polynomial. The second function is a trig function. So we have a polynomial multiplied with a trig function. Which choice should we select for you? Well, if we go back to our list, we don't have a logarithm. We don't have an inverse trig. We do have a polynomial. So that is the choice for you over trigonometry function down here, because that's the last one on our list. All right, so let's go back here. So in this problem, we are going to somewhere off on the side set u equal to x. Okay, that means the rest of this that is not x, all of this, all the rest of it is going to be equal to dv. Because that is the other thing in this integral on the left-hand side, u and dv. So dv is going to be equal to sine x dx. Okay, so we have kind of two things we're going to do now. On the left side of this, we need to figure out what du is going to be. So to find du, that would be finding the derivative. So the derivative of u would be 1 du, and the derivative of x would be 1 dx. Okay, on the other side, we also need to find in this equation at some point v. So we need to know, what does v equal? And to do that, we're moving now the opposite direction. We need to find the antiderivative on this side. So the antiderivative of dv would be 1v. Antiderivative of sine x, so we're thinking backwards now. What's the antiderivative of sine x? Would be negative cosine x. Because the derivative of negative cosine x is sine x. Okay, so now we know all the things we need to fill in this right side here. So this integral is going to equal u. So first thing we got to figure out is, what is u? So if we look over there, u is x times v. So we got to look over on the other side, figure out what's v going to be. That's negative cosine x. Then integration by parts formula says minus. So we're going to have a minus here. And then the integral, so we need an integral of v. So again, we're going to use v, which is again negative cosine x times du. And our du over here is equal to just dx. So this integral, if we can solve this out, will give us the answer to this problem. Now the left-hand part of this, there's not really anything to do. It's just x times negative cosine x, which is going to be negative x cosine x. One thing we could do to make this part over here a little bit easier, notice we have a negative and a negative. We can move this negative out, making this plus the integral of cosine x dx. Now we just got to figure out, to get the answer, what is the antiderivative of cosine x? Antiderivative of cosine x is sine x. And then this is an indefinite integral. We don't have any limits, so we put plus c. And that right there is the antiderivative of our original problem up here, x sine x. If you would go through and find the derivative of this bottom answer, it should give us the result of x sine x. That's called integration by parts. All right, let's try another one. On this one, they want us to integrate x to the fourth ln x dx. So again, start by trying to figure out what two types of functions do you have. This is a polynomial. This is a log function. So if we go back to our list, which one shows up first? Well, number one choice is logarithm. So we have a logarithm on this one. That is what we are going to set u equal to, is natural log of x. That means everything else is going to be set equal to dv, which would be x to the fourth. And there's also a dx over there too. All right, so going through like we did on the last problem, on this side we're finding derivative. On this side we are going to find the antiderivative. So let's see, derivative of u is du. Derivative of ln x, or natural log of x, is 1 over x dx. On this other side, antiderivative dv is v. Antiderivative of x to the fourth, we need to use our power rule here, go up a power. So x to the fifth, and then that needs the reciprocal of 1/5 next to it. All right, so now we want to write this out with the integration by parts formula. So we want u ln x times v 1/5 x to the fifth minus the integral of v, the 1/5 x to the fifth again, times du. Du is 1 over x dx. On this left part, it's just multiplying these two together. Typically, polynomials are written first. So we have 1/5 x to the fifth times ln x minus. Now over here, before we do antiderivative, I think it'd be better if we clean this up a bit. This is a constant. We can pull that out. These two terms, we should be able to multiply together. So writing this out, we got 1/5 times the integral. X to the fifth times 1 over x would be the same as x to the fourth dx. So now if we integrate that last part, antiderivative of x to the fourth, we've already done once. It should go up a power again with the reciprocal of 1/5 plus c, because it's an indefinite integral. The last step would just be simplifying, multiply these two together, and now we have the antiderivative here. So this answer right here, if we were to take the derivative of that, and we'd have to use product rule going through and doing it, you would get an answer of x to the fourth ln x if you go through and find the derivative. It's called integration by parts. All right, at this step here, this one, we again got to make some decisions here. What are we going to set equal to u, and what are we going to set equal to dv? Why don't you have a pause right now, see if you can pause the video, and then see if you can make your selections here and find the derivative and antiderivative. All right, hopefully you've had a chance here to check this. Let's see what you get here. So we have a polynomial, and we have an exponential, which is the best choice here. On this one, we don't have a log. We don't have an inverse trig one. We do have a polynomial, so that would be our choice here. So hopefully you pick to put u equal to 2x and put dv equal to the rest of that then, which would be e to the 3x dx. Derivative then of this side would be 2 dx. Antiderivative to find v. Now this one, a little bit harder. What is the antiderivative of e to the 3x? If you can't figure that out, you may have to think substitution on this one. What is the antiderivative of e to the 3x? So if this isn't one you can figure out, You might have to do substitution as well on this one. Maybe let u equal to 3x. Means du would be equal to 3. And so we made the substitutions here. This would be the same as e to the u times du over 3. So you get 1/3 antiderivative of e to the u du. Well, antiderivative of e to the u is just e to the u, so you get 1/3 e to the u would be the antiderivative. If we substitute back in, that means the antiderivative would be 1/3 e to the 3x. So if you can't do that in your head, then you may have to also use some substitution to help you with the antiderivatives. All right. Now, I want you pause again, see if you can write out the integration by parts formula and see if you can figure out what the antiderivative of this is. All right, hopefully you've had a chance here to try that out. You got 2x times v, which is 1/3 e to the 3x, minus the integral of that same thing v times du, which is 2 dx. All right, so doing some simplifying here, we got a couple constants we could multiply together. 2 times 1/3 is 2/3 x e to the 3x. Here we also have some constants, and since we're doing an integral, let's maybe pull those out. So if we pull those out as 2/3, we got to figure out what's the antiderivative of e to the 3x. We've already done that one. We know the antiderivative of this comes out to be, well, 1/3 e to the 3x. So we got this. Antiderivative of this comes out to be 1/3 e to the 3x plus c. If we multiply those two constants together, now we got the answer. 2/3 x to the 3x minus, this would be the same as 2/9 e to the 3x plus c. And that would be the answer. If you go on to take a Calc 2 class where you're doing some of this, you could also probably have this answer written a little bit differently, especially if it would be like a multiple choice question on an exam in Calc 2, because you got some similar things here that we could factor out. 2 and e to the 3x shows up in both of these, plus 3 and 9 both have a 3 in it, so you could factor out a 2/3 e to the 3x here. So another way you could write the answer would be x minus 1/3 plus c as well. So that would be another way this answer could be written. Okay, that's kind of an introduction to integration by parts. Hopefully those kind of understood the notes a little bit. We'll be working with that some more next week.